Hey Lois, Lois, we are not able to hear you if you are speaking. Nope. Is it me or everybody else also has the same problem?
We cannot hear him. Yeah.
Okay. No, Lois, we are still not able to hear you. It shows that you are muted, Lois. Hey Lois, it's showing me you're muted. So I don't know. Nope, we can't hear you. Okay, sure, we'll wait. Yeah, in the meantime, Louis joins. Did anybody get a chance to work on the things, able to get the better results? Did you guys try it out? Anybody? Or no?
No, Manoj, I didn't try.
Oh, okay.
Let's see if we can. No, let's see. Are you able to do?
I was, yeah,
You tried?
yeah, I did try. Yeah, but I was able to run everything, but yeah, batch size and learning rate is something I just changed it once.
Hmm?
I get time to make more changes and try it out.
I
But
did try with a couple of times changing the batch size and also the
IE?
inspired, but I didn't see much difference.
um,
It gone down when the batch size is low, but when it is up, I didn't see much difference.
okay.
So when it's low, what's the difference you've seen, Shashi?
Uh,
Like eval, or, I mean, loss, or I mean,
loss is lower percent, like 40%, 50% instead of like 60, 70.
mhm. Okay, okay. I was trying to understand the code, so but yeah, it's it's a lot of things in it.
All right, can you hear me now?
Yes.
Yes.
Yeah.
I think the issue was my laptop died right before the meeting. I think it may have, because the battery died, it may have like messed up some hardware. So I've had to restart it to make sure it's all good.
Okay.
Okay, so I think some individuals had questions around the code itself. I was hearing. Who wants to go first?
No, we were just trying to. We were just discussing about did anybody give a try making some changes and see if we get better results and fine tuning and other stuff. So we were just discussing a couple of those things.
Okay, cool.
Yeah. Yeah, go ahead, guys.
Yeah, that's good. That's cool. That's good. So, if people have any questions, we can go in them. If there's not, we can, if you want, people want to do an exercise where we can go in there and we just adjust a couple of parameters, see if we can make a big difference and see what happens, right? So let's start off that way. So let's start off with anyone has any issues, any questions, anything, any problem running the code?
So we don't have problem running the code, uh, but I just wanted to uh, uh, like let's do some tweaking and observe and understand little more detail and how, if we wanted to make changes, what areas we should be focusing, like different type of input and stuff like tweets and other stuff.
For sure. Okay, for sure. I'll take that as I'll put that in the notes of things of actions to do today. Adjusting parameters. Anything else anyone would like to discuss for today's office hours?
Hey, Luis, I have some unrelated probably question outside the scope of this probably. If everyone is silent, probably I can go with it if you're okay.
Yeah, let's see how let's see how far left is it. Yeah.
No, it is not completely out. When I say outside the scope of 103, but still with AI, right? So the my question is like, are you going to cover the MCPs, and then one is the MCPs, and the second thing is multi-agent ability to integrate it into the the idea of your choice, and then see like if the multi-agents how they interact with each other. We covered it briefly in earlier classes, right? You showed us in like as in hey, you are an administrator or you are an reviewer, something like that, right? Like, but you see them in action with the reasoning and like all of that stuff. Is it something that you're going to cover in this?
So we're going to be covering MCPs in week 3. So not this week coming up, the week after. I'll show
Okay.
you how to walk through how to create your own MCP servers, how to connect to it, all that. So that's been in sort of week 3. RAGs and agents is going to be in part of week 4.
Okay.
So we'll be covering a little bit more about how to do evaluations. And so again, not to get people confused and things like that. So what really is an agent? It's an LLM that's able to use a tool. So
Right.
when you put an LLM to call an MCP, that's building an agent.
Correct.
When you have an LLM calling an API, that's building an agent because you're
Yes.
giving them choice to build out their own tools.
Right.
And that's basically what an agent is. There's this saying in consulting that we say is if you squint hard enough, anything's an agent. So it's
Right. Yeah. No, I really meant a proper, like an agent, like which is an LLM, like sure, it's a wrapper around an LLM, like, but like you do some little bit of an massaging, or you do I mean, the thing is, like, obviously, like, given the context, it'll let it break up the natural language into the required parameters, like, and then not required parameters, actually identify the MCP tools that are out there, like find the right MCP tool, and like break up your context into a question that the that is required for the MCP, and then all of that stuff, right? Yeah, but I was just curious, like, the thing is, like, more around the what do you call that? Configuring your, like, for example, a cursor or something, right? Like with a multi-agent to be able to do the job in parallel, kind of a thing, right?
yeah. So I was thinking about doing some of that stuff in 104, in the sense that right now I just want you guys get to understanding a little bit more of how to connect your agents. Like before we did Wikipedia, and we showed you how to do a Python function and showing an LLM when to use either or. So this round, it's about, okay, let's connect now larger APIs. We connected one on last and Genai 101 with Tavily, remember? So Tavily was the internet search API, in which we created a chatbot that could go out and pull information from the web and pull it back. That's technically an agent, but you can have one that we call, like, I'll talk about in the week 4 about making choices, right? So not only you have your Wikipedia API, you could have another API, and then you can have the LLM sort of decide between both of them. But in order to connect to these APIs, you need MCP servers. And that's why week 3 is going to be really important to understand how MCP servers are the gateway to connect to your third-party tools and sources. So for sure, great questions.
One other thing, if no one has questions, then probably I'll ask a follow-up question, which is, have you come across people using the MCP servers as APIs?
So this is yeah. So there's a lot of things have changed since 6 months ago till now.
Right.
So before, MCP servers were just a connector to an API, like just simply just an API call.
Right.
But now MCPs have been evolving in the sense that now it's its own operator. So
Correct.
let's say before you would have a database, and you grab a database, and then for you to have a SQL query to it, you need to organize the data, you need to make sure the data is clean, you need to make sure it's all connected, you need to have all these different things. So now with MCP servers versus an API call, you can have an LLM understand your schema of your database. You can have an LLM understand how everything's connected. Have it be able to make certain, give it a bunch of different SQL calls that it will say, okay, I need to pull information from this area. So MCP servers are sort of that middle gateway that will go in, create those SQL calls, pull it, and then understand it before giving it back to the other LLM to comprehend. So we'll go deeper into this during week 3. But that's where everything's going. And what these LLM agents do is then they use the information from these MCP servers, and that's what makes them agentic.
Correct. Actually, like the reason why I asked this question, right? Like, we have an MCP server out there, which we have written, our folks in in a different group have written, right? I looked at that interface, right? Like, it's pretty generic, but let the LLM do all of that stuff based on the rules that are written, right? Like in our case, it's a cursor rules, because we haven't really published it as a remote MCP yet. It's a local MCP, so they have the cursor rules, like where all the context has been given. Hey, like you're allowed to check these tables, and there's a schema of this particular table, and like how they are connected, related, and all of that stuff, right? So LLM does the magic of like understanding your context and then building that query kind of a thing. But imagine if I want to take a stance that, oh, I don't really need an LLM for this. I'm not against the agents, but then in this particular case, I don't have an access to LLM, but I can reach out to the MCP, right? I know how to write that query because we know the data model really very well, and then I can write the queries well. So I just want to use that MCP because I don't need to do anything else, right? Like if I were to write an API layer, you need to do the dependencies, management, like security, auth, Z, all of that nonsense, correct? Everything is being taken care in the MCP. So why can't I just call it as an API in specific cases, not for all the cases, but it's a dual purpose is where I was heading to.
Mhm.
Is it a common pattern that you have seen?
So no, because again, like I said before, now things are getting more complicated because they want these agents to do more than just simply just call an API. They want them to do understanding and learning. They want you to take decisions. So it's saying, hey, you have, let's say something in your backend. Let's say you have a mobile app and you're doing statistics. And you want to have something that tells you, hey, something's off with your metrics. You want something that's completely off anyways. So this MCP server could constantly be running in the background, checking what's happening, looking at your data, then creates alerts, and then from this MCP server, they'll create alert that will send to your LLM that will then send in natural language, hey, we are noticing a spike in your data.
Right.
This is where again, I think it depends on your use case, but MCP servers are evolving a lot. And like I said before, we'll go through the week 3 and you'll notice for yourself when it's necessary, when it's not necessary. But again, if you want to do agentic work, which you give the model 4 different data sets that are completely different from one another, and then how to connect them all, an LLM is smart enough to do that.
Right. Okay. Thanks, Lewis.
No worries. Okay. All right, so there's a couple questions around hyperparameter tuning. So this might be a little difficult for everyone to grasp right at hand if you haven't delved into the world of machine learning or neural networks or sort of deep learning in that sense. Because hyperparameter tuning in a typical machine learning sense, whether supervised or unsupervised, are what we do to sort of train the model to do better. Remember last time we talked about how you can train the teacher model. If they make a big mistake, you make a bigger penalty. If you do other mistakes, you make other penalties. So what I did right now is create an interactive dashboard. Maybe I'll put this into the chat. I'll share my screen, and then we'll go sort of all over the concepts, and then we can add this to our data set afterwards, so we can understand what's really happening. So let me just pull this on my screen over here. I think it's desktop 1. Okay. All right. So everyone can see my screen?
Yes.
So I made this called, it's a little short thing called hyperparameter tuning dashboard. So this is for you to sort of understand what each of these knobs do. So think of this like a car, right? Each car has oil, your belt, your different functions that make the engine run. So depending on how much gas you put in, depending how much oil you want, depending of how much speed you want, you adjust your model and it'll try to give you better outputs. Like I said before in last week, but there is a way, there is sometimes something called overfitting, which you tune the model to the data so much that when you come to real life world cases, it messes up completely. Although you may have achieved like a 90% accuracy or 95% accuracy on your model, when you hit real world data, you may have very bad performance, and that's when something called overfitting happens. When you give too much tuning to your model and it doesn't learn properly what should be happening. So let's go through a deeper dive into some of these. It seems like these are the type of questions that you guys want to know. So let's go to them. So number one of the hyperparameter tuning. So again, going back to our data sets here, remember I sort of gave two at the beginning to sort of evaluate our two models on. I think it was here, which code it was. The first one, I just gave two basic one, batch size and learning rate, right? So batch size is the number of data given to the model, and then you have a learning rate, 1e minus 5. So why did I only do that one and then the other ones I did the rest? Because learning rate's actually the most important one. This one controls how much the model responds to an estimated error every time the weights are updated. So again, this is remember we did that quiz together. What happens if something was 100% confident, 50% confident, and you should get penalties, right? So right now everything's sort of given in a log type format. So going back to our format here, 1 minus E5 is a logged number, but you can adjust it to 2, 1, etc. like right now. So 1 minus E5 is sort of like the lowest number and sort of see how it moves the simulation, right? The more you move it to the right and you drop that log down, right? Like you want to make sure the model is smooth. And this is sort of where I was saying before, you can adjust what happens if you were to then increase the learning rate. What does that curve look like? Versus if you were to drop it down. So you want something super smooth, and 1 minus 5 is sort of like that sweet, smooth, like a straight line. But the moment we increase it, you're telling the model to give higher penalties, to look at the things differently. So it goes from that smooth line to sort of that curved line that we're seeing down below, right? But the whole point of a learning rate is that you want something to be very straight and curvy, right? And again, this is just a simulation on the right. If what happens if you were to add more learning rates to your model. Um, so again, here the loss is noisy. It may diverge. The model's overshooting the optimal solution, right? So higher the learning loss, the it becomes is noisy, it may diverge, and then it may be overfitting. So that's where we always want to keep the learning rate as low as possible to do better things. Now the batch size. The number of training examples utilized in one iteration. We talked about how we're putting, example, we used 8. Larger batch sizes can lead to faster training and more stable convergence, but may generalize worse, right? So although I think we had batch size 8, and we still sort of see that straight line, I think we had that before. But what happens if you were to batch size a lot? The loss jumps up very much, very high, and we're not getting to that 2 number where we were the day before, right? So around 8, the loss is sort of still the whole point, but we're trying to get like a smooth straight line that the model can train on, right? And you can upload it like a little 10, 9, 10 again. It doesn't really affect it that much. But once we start getting into the 20s, 30s, 40s, and 50s, you can see that it does affect, it makes it um, makes it very bumpy on that side of it. So although it may learn faster and stuff like that, you may make it generalize a lot more because it's having less data to think about and consume. All right, the third one we have now. So these are the two ones that I say the two top ones that you can adjust that actually would make big effects to the model. Now, these other ones, the smaller ones, are the ones that are now, okay, let's turn the knobs and see what we can do to sort of have a better signal. And we put those in the bottom here, right? So a number of epochs is a number of epoch is a single epoch, one full pass of the entire data sets. So you wanted to go and understand and learn everything from your data set once. But if you were to then have it go again and try again and try again, you can see the model, that straight line, right? If I said give it 9 epochs, 8 epochs, and try again, try to learn, 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 you don't want to give it at least like you can bring it over to 100 epics and stuff like that, right? The only reason when you would start adjusting the number of epics from 1 to let's say 30, or people even actually go to 100, 130, is because you want to again want the model to go over the data, go over it again and go over it again and go over it again until it actually understands the concepts. So as you increase the number of epics, it's the number of times that it actually goes through the whole different data sets um, from that way. So I'm going to pause here because we are not in teaching mode. So we can go from there. Any questions up to here?
So, Luis, it's the same data set it's basically the iterations, right? Like use the data set, learn, and then I'm going to give the same data set, but learn it again.
Yeah, so it does, because remember, everything is sort of put in a random set. So example, as you go in there and you do move it randomly, like you'll show, okay, here's the first data set of your test, right? Remember, we split the data set into three different categories: test, train, and validation. Where you test it is the data that you give to your model to give you your model to learn how to respond. Your test is when it uses to validate, oh, did I do good? Did I do bad? Okay, let's go back and adjust it. And your validation at the end is after you've gone through the whole test and train, you do it one more time, that last holdout set of 10 or 15% of your data set to go back and say, okay, um, once I train my model basically on 90% of the data, can I get that last funnel 10% going? Now, when you give the data to your model to learn, it comes randomized. So it might be in this 8 batches, lines 1, 20, 60, 50, and 33 is part of batch 1. But when you do the second epic, it could be lines 2, 12, 13, 40, gets sent to your LLM to go through that set again. So it does this because you want to be less biased with your data, right? So it could be a way that maybe the first time you give the number of epics of one, that somehow all the bad cases are joined together rather than being separated. So the model thinks, okay, everything's going to be a bad case. So then when you run your model, you might see it's classifying everything in a bad case. So again, that could happen that way. So that's when you have a number of epics, you're telling it to retrain itself again on the whole data set, but it's mixing your batches. So it's not the same exact batch every single time, if that makes sense.
Yeah, it does. Thank you. Yeah, because I was thinking more from the perspective of, like, what is it, like uh, yeah, I think that will come. The one I was thinking is probably will come into play when you have new features added, all that case. Here, we're not adding any new features. We are just tuning the parameters, right? So probably the model, yeah, that's fine. Because I was thinking about this, the challenger models, like as in, oh, you have model one, which is performing well in the production, but then, okay, fine, I'm coming out with a new model, probably with a different feature set, correct? So now I have a model A is pitted against model B in terms of challenging each other, and whichever wins will make it to the production, right? But in this particular case, no, it's basically you're training the model with the same data set, but with a different iterations, or like whatever. Yeah, sure, they probably did not match.
Yeah,
Yeah.
so again, I think this one important when you guys read through this is that too few epics can underfit the model. It hasn't learned enough.
Mhm.
So making it only less 2, 3, 4, or 5 is very low. I would say when we do this again, I think I put for just to make it go faster and for everyone that we're going with, I think how many epics did I put here? Yeah, to make it go fast, put 0.25, right? But we can then change that to 20 or 30 epics to see how better we can get the accuracy that way, which we can check out in a second.
Lois, when you say 0.25, is it like only 25% of the data it is getting trained on?
No, so again, 0.25 is only 25% of the data it's going to be consumed. So think of this as whole numbers. So
Okay.
epic, 2 epochs, 3 epochs, 4, and you can do 4.4, 4.5. So this 0.25 is 25% of one full epoch. So when we did this, in this example, this training, it's not doing a full epoch. It's only doing a quarter of an epoch. So I just did that just
Yeah.
to show the speed because again, when we did this, I think it took 2 minutes. But if I were to, we'll show an example. If I go up to 5 or 6 epochs, how much time increase it has. And this is sort of the issue when you start building LLMs. When you look at ChatGPT on these other areas and how many epochs they sort of been trained on, they've been training on thousands of epochs and lots of GPUs. So some of these models actually take weeks, even a month and a half to fully train some of these models. So these models are burning through large graphics cards, hundreds of hours, and churning and churning and churning, learning new rates.
Mhm. Thank you.
Louis, so I just like maybe my question maybe because I'm missing some basics. So I'm just trying to understand what's the difference we are training a pre-trained model versus an ML model, machine learning model training.
Yeah, so in week one, we sort of learned that NLM models are NLP models or machine learning models based off neural networks. So an LLM is a bunch of neural networks from NLP models that are working together to sort of look at which categories are being set and understanding the relationships between them. And for those who are sort of new to neural networks, what they do is they send information to thousands of nodes inside the neural network, and they bounce off each other, trying to find any single type of relationships they can. So when you do fine tuning of an LLM model, example, we're doing fine tuning of a BERT model here, we have to train a neural network, similar as we do in ML, for it to learn the new information. Hopefully that answers your question of why we do something like this.
Yeah.
Okay. I think number of X we talked about, weight decay. So again, these are now smaller penalties. You can say, okay, I want more penalty, I want less penalty. So this helps overfitting by keeping the waddle weight small. If it's too high, it can lead to underfitting. So again, you can bring this to 1 and it won't be too bad. But as soon as you start going over to 2 to 3, it could lead to underfitting. Warm-up steps, the number of steps at the beginning of training where the learning rate increases linearly from 0 to its target value. So warm-up steps is something that I didn't include in here, but again, these are extra hyperparameter tunings that you can add in to your model so it can be better. So again, why would you want something like this? Let's say again, it goes back to which business case. If you want it to be really, really good and you're at 88% and you're like, okay, I adjusted my weight decay, I adjusted my learning parameter, I moved this up and down, and I'm not getting more than 88%, then you can add in extra hyperparameter tunings and see adjusting these ones will then help you increase and get you to that 90% maybe that you're trying to achieve. Again, there are ways. Again, there isn't like a one all, and again, some of these aren't necessary. And sometimes you find that using some hyperparameter tunings, extra hyperparameter tunings from the beginning, can even hurt the performance of your model. So by removing extra hyperparameter tunings, you might get better results only using 2 or 3 versus using all 6 at the same time. So again, to me, it's about using the top ones you know that can adjust, and then slowly adding the other ones in to get a higher strategy and to do something that's a little bit better. And this is where data science comes from, right? Usually this is the work of AI engineers, machine learning models, engineers. was in the sense that when you look at this, it's more of a art and science that you need to understand, okay, if I adjust this and move this down, would I get a better accuracy? Or would I move this up and down, I get better accuracy doing this, right? So again, this is where that ML knowledge set, that ML discipline comes in and trying and understanding the statistics behind each one, because gradient accumulation is calculus, understanding gradient descent and how to optimize your GPU. More up steps again in L2 regularization is using statistics again of linear regression and using different techniques in linear regression called lasso, different things like that, to then find ways to penalize the LLM model. So these are very highly regulated statistical events that people do to optimize neural networks. So this is why you may have seen it once. You're like, whoa, what's all this information? Maybe a little hard to consume because this is sort of already a mature art that's sort of been created the last over 10, 15 years that people have gone in and been able to develop and find ways to tune these types of models. So hopefully that gives you a deeper explanation of what these hyperparameter parts are doing. And then let's go back and try to edit this. All right, so from here, I think I already collected our collection data sets. So let me just run this again. Okay, load our tokenizer models, make sure it's all loaded in. Okay, so I'm going to skip this part because again, we were doing something very simple, showing examples of it. Meanwhile, what we have here is, I think this is the evaluation. Let's get this part in. I think it's a full load of this model. So hopefully this will then run just below. And before we run it, we're going to do some adjustments, right? So this time we're going to change this to 10 epochs that we want it to go. Number weight decay, remember, so going back to what we said here, what should be our weight decay look like? So it helps prevent overfitting, right? But if it's too high, it can lead to underfitting. So let's do something that's not too high as 3, but let's say we move it to 0.01. What would happen? So right now it's 0.01. Let's make it to 0.10 or just 0.1 to make it look simple. And then we're doing our evaluation steps that way. So simply just changing two things. Our learning rate, I don't want to use the learning rate that we have above. Maybe we want to change our learning rate as well. So we could see that 0.105 was fine, but what if we change this to, let's try something to 1.0. I'll change it to 7 or something so you can see here. I think that's the number we used above. Let's just confirm 1e minus 5. So then we can go here. So let's go change it to 7. And then change our batch size to something less. So let's go to 6. And let's rerun this now. Now that we've sort of adjusted, we increased the learning rate. We decreased our batch size. We said we want to train it 10 times over. We increased our penalty and we kept the same evaluation steps. So let's see what happens. It may ask me for my API key, but we'll see. Okay, let me just grab it. Just copy. All right, so we'll just let it run for a little bit. If anyone has the old notebook available, maybe you haven't run this yet, so we can do a comparison of how the model is doing now versus how it did before. But we can look at the final accuracy as well, to see how it's doing. All right, any questions while this is running? This might take a little bit because again, I put 10 epics. When we first ran it, we did only 25%, right? So again, if it took 2 minutes to run 25%, now you think about, okay, if it's 25%, 2 minutes, times that by 4, 2, 4, 6, 8, 8 minutes per epic. Now you times that by 10, right? So this is how you see how long it takes you to sort of train these models, and go through the different areas and how they can be used. But yeah, this is sort of the activities I want you guys to work with, and sort of play with yourself again. It may be running in the morning, just having it adjust some numbers. What happens if I put it to 130 epics or 80 epics? Do I really see a difference? And this is where you'll see that sometimes that curve, you'll see a curve in your charts when you go back to WanDB, that after a certain amount of epics, it just drops. So you're like, okay, it drops around the 50 mark. So maybe if I fine tune it after any more than 50 epics, it's not really learning that much. So I'll just keep it only to 50 epics. Or after 30 epics, I'm seeing that it just drops completely. I only need to change it to only a certain amount that way as well. So again, that goes back to that science of how can you improve this and look and go from there.
So with this, we are monitoring the loss percentage, and right?
Well, it doesn't have to be the last percentage.
And
So this what it's doing right now is looking, it's sort of training itself on the batch.
yeah.
So it's looking at this batch and giving that accuracy percent and learning from that batch. And every single batch it's sort of doing, it's learning more and more, right? So we started at
And
30.
also accuracy, yeah.
Yeah. So now we're at 37, but it doesn't mean that 37 is the best it can do. It's just saying for this batch, it learned better than this batch coming up. So, but it's still learning how to answer and to categorize properly. So what you do at the end, again, you need to have this part here at the bottom,
Yeah.
because then it will choose eventually what is the best evaluation, how accurate it is overall, and then give you the best results from there. So this one only accurate was 63.3. I'm sure by doing 10 epics, we're going to see a little bit better result from that for sure. Well, we'll see if it ends at time. I think 10 epics might be an hour worth of information. Yeah, we're at 500 from 5,433, right? So I think it's saying that within an hour it's going to be finished.
Wow.
So this is where, again, and I only did 10 epics, and keep in mind that when you do fine tuning of LLM models, it could be 3-4 hours, 5 hours on simple this way. So this is why fine-tuning costs a lot, because again, we're running GPU, running hardware to get the responses. You're running how everything's sort of working that way as well. So that's how it works.
Yeah, compared to the batch size and the learning rate, I think Apex takes the amount of learning time more.
Exactly. So because I lowered the batch size, it's going to take more time to train because now it's looking at more individual results rather than 8 at a time. But let's say I jumped it over to 20, it would take less time, but would we get better or worse results? And this is where I wanted you guys to sort of experiment using those different things using this side. So what I could do is after this is done, I can leave this running and then I'll put in the WhatsApp group the little screenshot of our experiment of today, but if we were able to increase or not increase with these type of metrics, and then you guys can play around with it more to see where you're able to view. Because yeah, it's not going to finish now. It's definitely 49 minutes in. So my little bar is going to tell me it's gonna take a little bit longer.
Yeah.
Okay. Any questions while this is going on from that side? Anything else?
And also regarding the dashboard you shared, like that dragging and moving and all, how is it generated? Like how did it do the prediction?
Sorry, for which one?
You shared one link before, that interactive dashboard.
Yes.
So the chart changes. It is just hard coded to reflect.
Yeah, that one is just a demo. It's just a demo. The one I just sent you before is just more about teaching, learning how each model affects. I find visualizations and using tools like that could help understand the concepts more.
Okay.
But they're not connected to this.
Okay.
Yeah. But in your WANDB dashboards, that shows you the results of your fine tuning, and it'll show you the charts and see if you could see that straight smooth line, or do you see extremely wavy? All right, so for those who are joining first time, so remember, the office hour is meant for anything. It doesn't have to be about something specific here. If you have any questions about AI in general, anything like that, again, this office hour is yours. If you're working on a project and you get stuck, this is a time that you can also share with the class of things that you're working with, and I can help you directly. Office hour is meant for a bunch of that time, right? So don't think that you need to think about something specific every single time about the lecture code. Let's say you're working on something yourself. So we can definitely help with that as well during these office hours.
So I'm totally new to AI here. So still trying to wrap my head around all this different jargons and the code what you're telling. So I'm trying to understand like the data set what you're trying to train, right? Like how is this data set actually like is it RDBMS table or like how is it structured or unstructured data like?
Yeah. So this, for example, this data set that we're going to talk about that we went through here is Twitter evaluations. And again, next class we're going to go through is actually showing like through a conversation, but it's structured in a dictionary where you have your text and your label. When your text is in this Twitter results, the text of the Twitter, and then your label is 0. So it's very similar to if you know what if you worked with machine learning before or data science, things like that as well. In order to do a prediction, things need to be in numeric values, right? Zeros and ones. Your label, which is your target variable, needs to be in these numeric forms for this example, for this BERT supervised fine tuning, because again, it's an NLP model. So this model here has to have 0 if it's positive, 1 if it's negative, 3 if it's neutral. So you're giving a multi-class dictionary set to an LLM to train it on. So the model will say, okay, reading this text, that means so this text is, I can see all these words that are terrible, first world problems, can't, and things like that. That should be a negative response because the label shows 0. So you're training the model to see if you recognize any of these words come up, you need to label this as 0 as a negative response. So
Hi,
again, when you do your training data sets, we'll see there's different ways to do it, but for LLMs, this is one an example of that.
So for example, like I work in a product, like it's a PLM, product lifecycle management tool. So we have a lot of data that coming because like, for example, you have a part and we have some issues that come up. There is a change order that comes in. So we're trying to reduce the number of change orders or number of defects on the part that gets designed, right? So we have all this data that sits in a RDBMS, and then we have files, drawings for those, right? Like how do you train such that the users, when they're trying to model the part, like they don't, the system automatically trains to alert the user that this will cause issues in the future and so on, right? Like if you want to do that way, like you still use the same data set in the similar way to train the model, or is there a different format for such kind of training?
Yeah, and that's a great question. And that's something where I talked about at the beginning of the class, that fine-tuning is based, if you have a data set that you know is going to be like your Bible, that has to be like, it's could be your manual, could be anything that doesn't change. Like, you know for sure it doesn't change at all. You would use this fine-tuning to be the end-all case, because the fine-tuning model would have all the knowledge of what should happen, what shouldn't happen, etc. Right? But if you have constant churn and your data is changing constantly, you have new architectures, new drawings, new things that are happening, then fine-tuning doesn't make sense, because you're fine-tuning only when you fine-tune something, it gets frozen. And for you then to go and fine-tune, 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 and fine-tune again, you have to understand that constant fine-tuning costs money. Right now, using example, just doing 10 epics on a simple small data set of 500, and it's going to take us over an hour for each epic. So like one point right now, we're almost finishing our second epic, and it's been 15 minutes. So when you have large amounts of data and you want to train your LLM on these large amounts of data, you're going to have to train them for a long time, and it's going to cost money. It's going to cost $5,000-$10,000 at least. So if you constantly trying to update your model, and it has to be done every 5-6 months, fine-tuning is not the option. You would have to do something where it's either agentic, in the sense that it pulls information in and then validates against what's sort of being written, or you do a RAG, where you aggregate information in a vector data space, in a vector database, and it matches to what's sort of being written, what's happening. But for that to happen, based off what the criteria you're talking about, is that you need to have some sort of interface, that when people are writing into the interface, it's being streamed to an LLM, and the LLM can then start giving corrections. Think of it like GitHub Copilot, where you have the autofill, right? Of like, if you're typing, this is what it suggests to be. You can also have, when people submit something, a suggestion, just like how that text will, those codes pop up, to say, oh, you're working on this, check out these files. Or you could have it pull it to a link, or you could have it post to previous interactions, so then the user who's typing in can know that way, right? There's many ways you can sort of think of ways to improve that way. But the point is, you need to give the LLM that knowledge first. You need to figure out that information. If it's constantly being updated, they need to look at cheaper ways to feed it that knowledge first.
And so you have trained a particular LLM, right? Like, but if you, like in ChatGPT 4.4, now 5 came in, and you want to use that model, can use the same database, or you have to
For
read.
RAGs, yes. For RAGs, yes. For RAGs, you're supposed to be swapping out the model and then use because you're just feeding information to a model. But if for fine tuning, you would have to fine tune number 5 again. If you fine tune number 4 to be your response, but if a new model comes out, you would then have to fine tune that new model as well, and that would be an extra additional cost. Cost coming in. So again, the most cost-effective way is the RAG because you can swap out the LM, whether it be ChatGPT, whether it be Llama, whether it be other ones, you can always swap out the LLM and you can still get the same results. So you don't have to go constantly fine tune.
Thank you.
Hey, Louis.
Yes.
I didn't get a chance to kind of in the last class you showed us a file and you executed that, right? I did not have time to set it up last time during the class, and I was trying to do now. And can you just quickly explain the different sections in that, and then I just wanted to see if I'm doing it correct, executing it correctly.
Yeah, so just due to time, like we're running out of time on this side.
Oh,
And
okay.
in the
Probably
video,
next time.
in the video, I go through it. But one thing you need to understand, like one thing that a lot of people were tripping up in the video was that I didn't. There's a if your Google Cloud doesn't have a pip install evaluate, you need to do that before step 4. So you need to install the evaluate package, and if you download the package, you should be able to run everything. And it seems to be a thing that people are running.
Okay. Before step 4.
Yeah, so I think it was at the notes were on.
Okay, and by the way, I don't see step 2 there. I just see step 1 and 3.
9, 10, 11. I think this is step 12, sorry.
12. Okay.
Yeah, these numbers aren't these numbers aren't matching up to the codes here on the side.
Oh. And did you say pip install evaluate?
Yes, you need to put that before you get, so before you see trainer integration. Before that one, you need to put pip install evaluate in order to make the second part run.
Oh, before the trainer integration.
Yeah. So right after trainer integration, you put pip install evaluate, and that should your next code should be able to run.
Okay.
All right, I think we are at time. I can take one quick question before we head out, but I think we can continue if there's nothing else. This one looks really hopeful. Like we're at, I think, only 30% and we're at 0.45. So if the model continues going and we still have a lot to go through, and I think, yeah, we're at 2.34 and it's already at 45%. That means we're only 20% away from the 60 it was when it first evaluated, right? So you could see that adjusting these knobs, adding more training methods will definitely improve the process. And I'll again, like I said before, after this finishes running, I'll do a screenshot of the final accuracy of this, and then add the hyperparameter tunings changes I did for today for you guys can look at as well. Okay, thank you so much for joining today. I'll stay back for 2 more minutes, and then if anyone has any last minute questions,
Yeah, Luis, I have just a different question, a completely different. So, given audio and then few videos of a person, I would like to generate a lip syncing video actually. Do you know, like, is there any good working model which works? I tried few, but not much luck.
So lip syncing videos, I haven't done a lot of vision work. That said, is it just dubbing over, or is it?
Yeah, in the sense, let's say I know someone, he gives great lectures, let's say, and then I have a lot of audios of him, but I don't have videos for all of those. So then for the whatever the video is missing, given the audio from that person, I have the audios. So then I would like to use some of the existing videos to mimic the lip syncing, so that now for every audio there could be a video as well.
Yeah, I haven't gone down the video route yet, so I haven't done the video yet, but that'd be an interesting project for sure. You would have to use a multimodal models to do something like that for sure. The only thing I know so far of sort of using something like that is sort of these CGI deepfake these different areas that are going and using that information. They're doing, a lot of people are now doing a lot of dubbing. A lot of people are now saying, there's a lot of people I noticed on YouTube, there could be one person speaking a language and then you have AI to overwrite what they're saying in a different language. So if you're in India, you can speak Indian. If you're in Spain, you speak Spanish. Like then there's an AI voice that dubs over their voices as well. That's the most I've seen so far in terms of voice, but I haven't done anything with video, so I wouldn't don't know that much yet for that
No
one.
problem. Thank you. If you come across any, please share in the WhatsApp group. That will be helpful. Thank
Yeah, for sure. I'll see if I can find where I can find from there. Okay, awesome. All right, thank you so much, everyone. Hope everyone has a great night.
Thank you. Bye.
Thank you too. Bye.
Bye.
Thank you, Luis.